Hello students, this is Dr. Satish Singhal, PhD, Professor of Computer Science, El Camino College, California. So this lecture is online lecture for the week number 3 of March 2020, and we have already finished all the basics of if and else selection structure, including nested if and else, which we will use in this design example. So this design example kind of helps you to study and learn how input-output analysis and algorithm of that software is done, which includes nested if and else structure or if and else structure. And the new animal that's thrown into the mix is that there are Boolean conditions, and then we have to figure out what is the sequential structure algorithm under the scope of those Boolean conditions is. So today's lecture will be in 3 parts, 3 different videos, and we wanted to make sure we do that for the sake of convenience. So this is CS1 design example 3, making decision software, part 1 of 3. And in this video we'll do input, output, and analysis. In part 2 video we'll do the algorithm, and part 3 we'll run the source code. Okay. So here we will see the Pythagoras Theorem application using nested if and else. So let's go to the problem statements. Pythagoras is credited to have discovered the theorem that applies to right angle triangles in Euclidean space only. If I connect 3 stars with lines, that will not be Euclidean space. Okay, and theorem is given like this: b square plus p square equal to h square, where b is the base of the right angle triangle, p is the perpendicular, and h is the hypotenuse. Actually, until one decides to find sine or cosine of angles in the right angle triangle, which of the side forming right angle is base or which one is perpendicular is arbitrary. Okay. So in this computer program that we are developing, user would input, first they will choose what they want to find, whether they want to find base, hypotenuse, or perpendicular. Based on what they want to find, they will input 2 sides of the right angle triangle, and program will use Pythagorean theorem, this one, to compute the 3rd side. So these are the choices to the user. They may want a base computation or a hypotenuse computation or a perpendicular computation. In each case, if we want those two, these two will have to be provided. Okay. So let's call that choice B. So base computation will be done only if user data was such that hypotenuse was larger than P, because hypotenuse is the largest side in a right angle triangle. Or user may want perpendicular computation when hypotenuse and base are given. Let's call that choice as P. And there is a if condition there that perpendicular computation can only be done if user gave us such a data that H is greater than B. And of course, 3rd computation would be hypotenuse computation, where B and P are given. Let's call that choice as H. And we're doing some additional things in this program. Output will be undetermined side, that side we want to determine, computed 4 decimal place. This will decide our set precision, and program will echo print user data to feedback to them, like what are they entering. Echo print means whatever they entered, you just echo it back to them. So before we write source code, we're going to do IOA. In this video, I'll finish up to analysis. So as you know already in IOA, I stands for input. So what are our input variables? So basically, I'm choosing variable names right here. They should follow C++ rules of variable naming. I'm choosing their data type, and I'm making some remarks on them because that will help us to prompt user correctly entering a data type. Okay, so first variable choice, that determines what they want to compute, hypotenuse, base, or perpendicular. And a good data type for that is char, P for perpendicular, B for base, H for height. But that would be a constant, so it's not going to conflict. If we decide to use P, B, and H for user side input also, that's fine, because their choice values would be P, B, or H, which are actually character constants. So user will be prompted to enter a char, P, B, or H to indicate type of computation they desire. User input will be converted to uppercase by the program, just in case they enter a lowercase letter. Now, choice of char, choice can be other data type like int. You could use 1, 2, 3. But char is more intuitive in this case. So that's why we chose that. Now, hopefully by now everybody knows that if you take side of a triangle, it does not necessarily have to be a round number. So sides of geometrical figures, just like money and dollars and cents, the reality of life is they can contain whole numbers, but they can also contain numbers with decimal parts, which we call real numbers. So obviously for base, perpendicular, and hypotenuse, these are the variable names we chose. Data type would be double type. So value of the base of the right angle triangle, if user enters a negative value, its sign will be ignored because real dimensions cannot be negative. And if user enters a 0, then we'll display the message that computation cannot be done. And the same thing for the other two. If user enters a negative value, its sign will be ignored. If user enters 0 value, the message will be that computation cannot be done. And same thing with the hypotenuse. So that's our input table. User will enter their choice. Value of base, if they base and perpendicular, if they want hypotenuse deduced, or any other combination basically. Okay. So anytime you feel you didn't understand something, pause the video and go back. And of course you have paper copy of this, so you can read that, write your questions on that also. I'll also put a discussion forum for each lecture, and you can post your questions there, which we can answer. All right, let's look at the output variable table. So depending on the user choice, one of the variables mentioned in input table above will be computed. And that is the one whose value is outputted. So an output format is to display all numbers to 4 decimal place. Echo print input is done. all output is done to user's console. Display may be affected by how user may set up their console. So notice that we don't have to declare separate variables for output in this case, because if we compute this, these two will be provided. If we compute this, these two will be provided. And if we compute this, these two will be provided. So we'll just use the same variable to output. One of the three variables will be outputted, other two will be inputted. So we don't need to declare separate table of output variables in this case. That won't always be the case in different software, but just happens to be in this case. But we are going to use some program constants and some other variables which are used in the software. We're going to use char constant b, quote, b quote, which will be used to compare user choice if base computation is decided. So whatever user entered, the value of this choice variable, we'll compare that with these three, b, p, and h, those are characters. And wherever there is a match, we'll do the desired computation. If user inputted choice is this, we'll do the computation of the base. If user inputted choice is p, we'll do computation of perpendicular. And if user input choice is h, we'll do computation of hypotenuse. And I could type this every time, all your input must be positive and non-zero, but I just create a string constant and I'll just display that. So that's the input output and any constants or variables that I'm using in the program. In this case, just happens that I'm just using all the constants, which will be declared globally in the source code. Okay. Now analysis part, in this case, because we are shifting to decision making, if and else, has two parts. And from now on, once we enter the loop, learning loops, there could be 2 or 3 parts. So more complicated computations you do, more your analysis will be having more depth. Okay, so analysis and first 2 labs were pretty easy. We just did the math formula and their computation to C++ form. That would be done here as well. But the new animal, like which Boolean conditions are true and what should be done under the scope of their truthness, comes into place. So analysis will be multiple part. First part is math formula in their C++ form. Notice the order: math form in the left column and C++ form in the right column. In your lab 3, you have to use the same structure. The other thing you'll notice, all expressions are numbered. And you'll have to do the same thing in your lab 3 analysis formula. Okay. So if I need hypotenuse computation, my math formula is this, that is the square root 0.5 power of base square plus perpendicular square, and in C++, square root is done by function sqrt. I know some of your brain is racing. I can use POW with 0.5. No, you don't want to do that. SQRT is given just for that purpose. So there is no need to use POW. Okay? And SQRT is faster than POW function. So that's why we use it. So math form here, C++ form here, expression 1. If I want base to be computed, then it is hypotenuse square minus perpendicular square square root, and that's the formula in C++ form, and correspondingly for the perpendicular. Okay, So that was pretty simple. In your lab 3, we gave a prep work in lab 2 where you had to compute the quadratic formula and get the value of the roots. If you did that wrongly at that time, you can go back and do it correctly right now. Notice all expressions are numbered, okay? And in fact, I forgot one thing. Let me do that right now. All line has to be numbered also. So let me just do that right now. There you go. And when you submit your IO of lab 3, all your lines have to be numbered just the way I did it here. Okay. So now the new animal in analysis is table Boolean conditions, and when a certain Boolean condition is true, what is done? And of course, when it is false, you will relegate the task to an else condition, and we'll talk about that too. But right now we're going to talk about what is algorithmic task when a Boolean condition is true. And this could be layered, like I would say, okay, if this is true, choice equals B. If that is true, I give a summary here, but I have details in the block 1. I call this layering. There's one layer here, but then there's another layer here. And you have to show clear logical layering when you do the table of Boolean conditions and algorithmic task done in your lab 3 IOA. And this is a statement of the future of things to come. Anytime software requires decision making or looping, table of Boolean conditions required. What are the algorithm tasks when certain Boolean condition is true is required. Without that, you're not actually doing analysis correctly, or you're not actually doing a big major part of the analysis. Okay, so if choice equals B is true, user entered something and this happens to be true, then use expression number 2 to compute the base. That's the expression 2. And output the result to console. And details are shown in the second layer, block 1. And if choice equals P is true, then use expression 3, this one. And this is in your handout. And use expression 3 to compute perpendicular and output the result to console. But if choice equals H, we will see details in block 3, but use expression 1 to compute hypotenuse and output the result to console. That's the expression 1. And the details are in layer block number 3. Now we see now layers. So layering is being done here. So we want to find base and output the result. So we are going to be testing 2 more conditions here, that hypotenuse or perpendicular is not 0. If they're non-zero, I can do, sorry, they are 0. If either is 0, I can, obviously, base computation is not possible, okay? But if either of them, opposite of this basically, that both being 0 is false, okay? If both being 0 is false, then obviously we can do the computation using expression 2, this one. So that's block 1. And block 2 is the similar case. We are computing perpendicular. If either hypotenuse or base is 0, then it's not possible. Else, it is possible and we can compute perpendicular and output the results to console. And block 3 is the hypotenuse computation. If either is 0, perpendicular base is 0, can do it. If either 0 is being false, that means both have some non-zero value, then we can use expression 1, which is this one, to compute the hypotenuse. Okay. So in Boolean conditions, part of the analysis, we have this layering. We show first layer, then we show second layer, and there could be third layer if software needs to make a lot more decisions. Okay. So this is end of video part 1 of 3. Hopefully you have understood input, output, analysis, both parts of it, math analysis, analysis of Boolean conditions, what is included to be done as an algorithmic task when a Boolean condition is true, and what is done when it's false, and how the layering is done. Layering is very important to keep the structure clear. First layer, and each layer has a sub-layer, like this one is expanded as a sub-layer here. So this structure has to be followed in analysis of Boolean conditions in your lab 3. Okay, so that's end of the part 1. Dr. Satish Singhal saying goodbye from part 1, and very soon I'll see you in part 2, where we do the algorithm based on our input output variable naming and analysis. Thank you.